Dear participants, as many of you perhaps know, Iceland is blessed with widespread geothermal resources of various temperatures we define as low, that is below 120 degrees Celsius, medium or 120 to 200 degrees, and high, that is above 200. Reading our sagas, there are indications of the utilization of geothermal water for bathing since the settlement of Iceland. Some of the early stage pools mentioned in these sagas are still known, and in some cases still used by locals and travelers alike. The reporting of exploration drilling goes as far back as to the year of 1756, where the first known steam blowout happened, luckily without accidents. The use of geothermal water also goes centuries back in time. Some landmark locations in the country serve as witnesses to this history. Known house heating starts with a farmer heating his houses just outside the capital in 1908. The first school in Reykjavík was heated in 1933, and the formal startup of district heating companies was a decade later. The installation of the first geothermal power plant was in the northern part of Iceland in 1969, 3 megawatts electric and still active. As of today, we have geothermal power plants in 7 different locations in the country. 3 of those are combined heat and power, that is the top 3 on the left-hand side of the slide. Together they produce 500 megawatts power and more than 620 megawatts thermal. The total geothermal power production counts for more than 750 megawatts. Given the richness of high-temperature resources in Iceland, most of the geothermal power production is made by utilizing these resources, using steam to turn turbines and generators, so-called flash technology. There are, though, examples of the utilization of lower temperature resources to produce electricity, where binary systems apply. Effectively, almost 90% of all households in the country are heated by geothermal. The rest is heated by electricity. This is a unique situation, whether you look at it from an environmental point of view, from the point of macroeconomics, or from the point of standard of living. In a country with harsh weather conditions, one can only imagine the effect geothermal heating has on the standard of living of the common people. We are now in a position where more than 82% of our primary energy consumption is fulfilled by green local energy resources, more than 64% by geothermal and almost 18% by hydro. Oil is basically used for transportation on land and sea, but with current technological development, we foresee this to significantly decrease in near future. Electric cars are rapidly increasing in the country, and electric fuels may, sooner than later, drive our fishing fleet. As one can see from the right-hand side of the slide, this has happened in just 50 years, where the utilization of geothermal is key factor. Although vast majority of geothermal energy is used for space heating and electricity generation, it comes useful in many other cases as well. Fish farming is one, snow melting another, not to mention the heating of more than 100 full-size outdoor public swimming pools, along with tens or hundreds of smaller ones, and a hot tub at every second household, or even more. One of the wonders of geothermal is the variety of possible usage. The type depends on the temperature, but as this slide shows, there are many possible applications. Combining the use, of course, enhances the feasibility, as for an example where the steam from a high temperature resource can be used for producing electricity, then using the hot water for space heating and growing tomatoes in greenhouses, fish farming and snow melting. In addition, geothermal makes an attribute to various industrial applications, being it for drying, process heating, washing, production of CO2, or even refrigeration. Here are a few examples of the daily use: snow melting sidewalks, processing seaweed, salt production, fish farming, and growing tomatoes. Now, A few words on the possible future of geothermal power, a project called the Iceland Deep Drilling Project. The idea is to utilize supercritical fluids at temperature of 400 to 600 degrees Celsius and pressure of up to 220 bars. A project like this, going far deeper down to the earth than usually for geothermal, expects various challenges. Theoretically, the power from one well of this kind could be up to 50 megawatts. So far, 2 wells have already been drilled, with a third well planned. The first well was drilled in 2009 and reached magma at around 2 km depth. The estimated power output was 20 megawatts. It did not reach supercritical conditions and was closed due to imminent casing failure. The second well was drilled 5 years ago. It reached 4.6 km depth, where the temperature at the bottom was estimated to be around 600 degrees Celsius. Again, casing was a problem, so testing has not been performed yet. Ladies and gentlemen, as stated in the beginning of this presentation, Iceland is truly blessed with vast geothermal resources. This has been extremely beneficial for the inhabitants as well as the environment. This picture was taken in central Reykjavik, our capital, in 1933 and shows the effect of smoke from coal heating. Another picture, almost the same view, but now without pollution, truly makes a difference. Finally, a few words on ISOR, or Iceland GeoSurvey. With 75 years of experience, ISOR provides services domestically as well as internationally and focuses on geothermal energy. Our staff is well educated, experienced geothermal specialists, and as you can see from the map, our clients come from almost every continent. Thank you for your attention.